So aside from just understanding the definition from an inversion, here's the single most important thing, the big thing we need to take away from this section if we want to be able to do our hyperbolic geometry model later with inversion. If I have a circle of center O, radius r, which is going to be the circle of inversion, which could be the unit circle in our hyperbolic geometry model, and I have 2 points that are not collinear with the center, okay, which could be outside the circle in this problem, but in our model they're always going to be inside the circle. If we find the inversion of either of those 2 points and then construct a circle through the 3 points, it will be orthogonal to the circle of inversion. That's how we're going to actually define our lines. Remember, lines are undefined terms. In hyperbolic geometry, the plane, the entire universe for hyperbolic geometry, one model is the Poincare disk. It's going to be the unit circle. Points are points inside of that. Lines are either diameters. If the 2 points actually lie on a line with the center of the circle, the lines will be diameters. Otherwise, we're going to define it to be the unique circle. It actually is unique, the circle that passes through P and Q and is orthogonal to the original circle. I've got a couple of other points here that I've constructed the inversion of one of them. Let me go up and get the circle through 3 points. That's how we can actually get multiple parallel lines that pass through points. Let me do one more. So that point, I have to type a command in, is D, is inversion. I want to do O, radius R, D. So I'll move them around a little bit. These two, the parts that are inside the circle, are actually lines that both pass through this point. They're defined to be lines in hyperbolic geometry because they're both parts of circles that are orthogonal to the original circle, and they pass through that point. Neither one intersects the line PQ over here. So in hyperbolic geometry, I can have more than one line, with our definition of a line, through this point that is parallel to the line PQ. And that's it. Inversion gives us a way to construct our lines in hyperbolic geometry, which are actually parts of circles that are orthogonal to the unit circle.